Since 2019, Australia's Parkes Murriya Telescope was keeping an eye on our nearest star Alpha Centauri, also known as Proxima Centauri, for many months. It basically wanted to find out whether this star can sustain life on the rocky planet Proxima B, revolving in its habitable zone or not. But during this research, an Australian undergraduate, Shane Smith of the City, detected a very strange radio signal. And it was strange because when Smith made his observations, sharing it with seniors, he observed that the signal was not like any other natural signal present in the universe. In fact, the structure of that signal was similar to the artificial signals produced by us. That is, that radio signal was falling in a narrow band range of 982 megahertz, which is usually used only by artificial satellites and spaceships. But then, after this, the astronomers thought that maybe we are getting our own signals bouncing back. So they studied those signals again, and after that verification, it was confirmed that the signals we are getting were not related to our Earth at all. These were coming from somewhere far away from interstellar space, and that too with regular fluctuations. It means that it can be said that the source of this signal is in a periodic motion. Now, since the frequency at which we received this signal is the one used in satellites, and as we know that satellite follows a periodic motion around the Earth, it was a hint for the scientists that perhaps this is the signal of a satellite created by some extraterrestrial life, and that is why the scientists named it Breakthrough Listening Candidate 1, or in short, BLC-1. But these strange signals were not the only reason due to which there was so much hype in the scientific community. This hype was that the signal came from the general direction of the Proxima B planet, i.e. its overall macro direction. We cannot pinpoint where it came from, or whether it came from this planet, but we are considering it to have come from Proxima B, because this is the planet which is the closest Earth-like exoplanet to Earth, and is currently passing through its red dwarf host of Proxima Centauri in a habitable zone. Now, to verify this claim, Smith and his mentors have directed the telescope to fly in the general direction of Proxima B. He removed it and looked, and surprisingly, as soon as he did so, the signal stopped being detected. And of course, this thing cleared all his doubts, and it was proved that the signal is coming only from the Proxima Centauri. But again, friends, as I said, from the general direction, that means this signal can be generated from anywhere in that entire Alpha Centauri star system, right? So then, how can we say with certainty that these signals are coming correctly from Proxima Centauri? In fact, some part of this star system is hidden from the entire northern hemisphere of our planet. You see, because our Earth is round, we can never see the entire sky at once. A very large part of the sky near our horizon always remains hidden from us, like a blind spot. Just like, for example, people living in northern MSP cannot see the sky of southern MSP, and vice versa. That means there are some stars which we will never be able to see in our entire life while staying in the northern MSP. So now the Proxima Centauri system, which we are talking about, is a part of the Centauri constellation, which is mainly in the southern hemisphere of the sky. If we have a telescope and we want to see Proxima Centauri while staying in the northern hemisphere, then we will be able to see this star system only by staying in the region from 0 degree, which is the equator, to 29 degrees, i.e. Delhi. People above this latitude will never be able to see this Centaurus constellation, and then no matter how big and advanced telescopes they have. But despite this, scientists can say with a good estimate that such an artificial signal can only have come from Proxima, and how? So first of all, we have to try to understand the Alpha Centauri star system. In the middle of this system, there is a binary star system in which two dove stars, like our Sun, revolve around each other, and around this system. Our nearest red dove star Proxy, my Centauri, is revolving around it. In this entire system, these exoplanets were detected only around Proxima Centauri. And out of them, only one planet falls in the habitable zone of this red dove. That is, all in all, everything is pointing towards the fact that these strange signals are probably coming more specifically from the Proxima B planet of this Proxima Centauri. But there is a problem here too. Proxima Centauri is a red dove star, which is usually very unstable. They keep emitting ionizing radiation like X-rays every day. Now, our Earth also receives the X-rays coming from the Sun every year. But if we compare both, then Proxima also receives about 500 times more dose of X-rays than the Earth every year, and sometimes even more than that, due to the unpredictability of red jobs. I mean, just take the example of March 2017. That day, the flats of Proxima Centauri suddenly became 1,000 times brighter in just 10 seconds. And if our Sun ever did this, then understand that our thick atmosphere also can cause us third-degree burns. Third-degree burns. It will not be able to save us. This simply means that we are probably reaching a conclusion about the habitability of Proxima B earlier than necessary. Just think about it. When the experts were studying the signal that broke through Listen Candidate 1, they noticed one more thing apart from the points mentioned earlier. They noticed that even though the detected frequency in the range in which the signal was observed is mostly used by satellites and spacecrafts, and they eventually also noticed that the signal was detected for about 30 hours. Now this is all because usually such things pass very quickly when seen through a telescope. That is, it is still not confirmed whether the signal was sent by an alien satellite or spaceship. In fact, Francis Murchus, a senior astronomer at the SETI Institute, has himself said that out of the 30 crore or so planets in our galaxy which are possibly habitable, 2 neighboring solar systems located in the same corner of the galaxy have similar technology, which in itself is a matter of opportunity and attention. If we think about it, how is it possible that our satellites and their satellites work in the same frequency band range? I mean, we can prove this by using basic probability. Let us understand this with a simple mental experiment. Imagine that you have 100 dice in your hand. Now we know that on rolling one die, the probability of any one number, let us say 6, coming on top is 1 by 6. That means, according to that, if we roll 100 dice, then the top number of 16 of them will be 6. Now if we add this condition to it, all these 16 dice with the same number should fall at the same place. That too in the first year attempt. So what are the chances now that what we want will happen? Obviously, even lower than the previous probability. This simply means that a perfect outcome is always the result of a random process, which does not easily repeat again and again at the same time and at the same place. And this is the reason that even though the Proxima B planet is very similar to our Earth, finding intelligent life, there is still a dicey game. But maybe the most recently launched James Webb Telescope can help us in this mission, with the help of its more advanced and sensitive directors. In fact, just last year, a paper was released in which it has been talked about detecting artificial lights on Proxima B with the help of James Webb Space Telescope and the soon-to-be-launched Loyer Space Oxygenator. Their claim was that since Proxima is orbiting so closely around its host star, Proxima B must also be tidally locked like our moon. That means, in such a case, there is still a possibility that an alien civilization is developing on its dark side, away from the heat and artificial lights. Like torch LED tube lights are being used to see in the dark. Seems logical and interesting, right? Well, no. The scientists associated with Breakthrough Initiative are not convinced by this, and neither am I. Just think about it. The chiefs who evolve in the depths of our oceans, do they need artificial lights? No. They create their own light, i.e. bioluminations there, or survive on the basis of their other senses in the absence of light. So why would the alien civilization that evolved on the dark side of Proxima B use artificial lights? And that is why instead of artificial lights, we should try to detect the bioluminescence of living organisms inside the oceans of Proxima B. This is why scientists associated with the Breakthrough Initiative are working on a breakthrough starshot project. According to their plan, kite-shaped probes made of light and strong material will be accelerated with the help of powerful lasers, with the help of which these probes will travel almost like the sail of a ship in the interstellar ocean at almost 20% speed of light. We will be able to do this, and then these probes will reach Proxima B and send us back detailed information about its atmosphere and magnetic field, meaning we will be able to know better whether Proxima B is habitable or not. But until then, the BLC-1 signal will remain a little doubtful. Just like the 1977 WOW signal, because the only thing we know about this signal is that it came from the direction of a sun-like star located about 1,800 light-years away from Earth. in the Crooked constellation, 2-matched 1928, 1982 264 0123. So is the hunt for aliens stay on? Well, definitely yes. Today, researchers are continuing on both the WOW signal and the signal received from the direction of Proxima Centauri. Although we cannot say with certainty at this time that these signals were created by aliens, but the thought that some extraterrestrial life using technology similar to ours can exist in this universe forces us to ask, how would an alien life survive? How would it have evolved according to that particular planet? I mean, when we imagine an alien, we imagine a big head, skinny body, grey skin and big eyes, right? Which is scary. But what is even more scary is this. It will happen if aliens look exactly like us humans. And then how will we be able to tell who is a human and who is an alien? And with that, friends, so what do you think, friends? Are the signals we are getting from Proxima Centauri alien signals or not? Is there any other reason behind it? Write your answer in the comments section below. And if you learned anything new from this video, then definitely give a like. See you next time, friends. Till then, as always, take curious and keep learning.